The backyard is a place of relaxation for all ages, yet many recreational facilities target only one age group. Ideally, people of all ages would be able to have fun together and alone using the same device. To this end, we present the Wind Whisper, a large circular structure with bells hanging from the top and 3 legs in the ground supporting the weight. Each bell produces a light and a unique sound upon being accelerated, with the playing being done by wind and people in a normal situation. The bells are ordered by length, where length indicates pitch and allows users to create music. The exploration and control over the bells and the goal give a sense of autonomy, whereas producing a nice melody makes the user feel competent. Besides, the Wind Whisper also has a game involving the lights. The mechanics should incite curiosity as the bells can move, emitting light and sound without human input. Once users are at a certain distance from the Wind Whisper, the light will move around the bells, and the goal is to move the bell as it lights up. Doing this results in a rewarding sound being played. Lastly, the different modes of playing and the circular space can encourage users to feel connected. The 3 legs in the ground support the structure's weight, and the round-shaped space invites multiple players to play inside and outside freely. This enables diverse playfulness by applying ergonomics knowledge. Hence, the Wind Whisper is designed purposefully. It lacks a finite goal or fixed rules of play, which offers freedom to each type of player, allowing them to create their own ideal playful experience with the tools at hand. Ideally, chimes will be hung on a circular structure with a diameter of 2 meters, which gives enough room inside the circle for players to move around. Besides, this ring will be supported by 3 thin sticks standing in the ground, so players can pass through the installation freely. The RIFD motion detector will be installed in the ground to detect users' presence. Each bell is constructed with laser-cut wood, hanging by 1 meter long wires connected with ADXL345 digital accelerometer V2 and LEDs installed inside the bell. The accelerometer can detect the movement of the bell and transport the signals to Arduino Uno R3 and laptop to play light and sound in Arduino and process through the wires and breadboard. We also attached a cover and tassel to each bell to make the design more inviting. A light strip will be installed in the circular structure. The moving bell will activate the corresponding LED unit to light up in random mode, and the lit LED will entice users to fiddle the bell in the lightning mode as well. Because of the limited electronics and budget, we only realized part of the ideal prototype, which is using acceleration to activate light and sound. As you can see, once the bell is moving and reaches a certain acceleration threshold, LEDs will light up and sound will be played. For future development, we aim to construct the whole structure and program more complex and subtle playing methods. The design process went through 2 iterations. Multiple ideas formed at the beginning. For the first iteration, the main ideas focused on light and relatedness. Firstly, there was an idea of 2 lamps in separate homes, both producing the same output, even though only one lamp received the input. The problem with this idea was that we thought it wasn't playful enough. Another idea was a flower-like lamp design that required long-time cultivation. Sadly, the realization of the product seemed too complicated, and it was commented that no free play space was provided. After the analysis of different playful objects for one of the assignments, we found that the playful experience is often based on objects that are playful themselves, such as musical swings and cello play. Our group got inspired and came up with the idea of constructing multiple interactive wind bells. The design result is a simple musical instrument. The user testing proved that this idea is intuitive, creative, and has playful potential. Additionally, users experience a relationship between musical notes and emotion. The feedback from the tutors instructed us to construct the design by utilizing the nature of wind, thinking on context and play stages carefully. Based on that, for the technical realization of the second iteration, although there were multiple options to realize the idea, such as using a joystick or air pressure sensor to detect input, we chose an accelerometer, as this solution to implementing the idea allows the mechanics to simulate regular wind chimes as closely as possible. Furthermore, we designed a cylinder space in the backyard for players to play inside and outside and play with multiple players. This space creates spatial freedom and playfulness and a round interaction zone for different interactive stages. The design evolves from basic mechanics to playful dynamics and finally to aesthetics, which happen in this round space. Even though we only realized limited technical function, we still built the whole scaled-down construction. In the second user test, we used the playtest and think aloud protocol and prepared the notes from different instruments to see whether the player's behavior would be influenced by them. The test results showed that when the participant heard different instruments, such as a drum or bell, they would try to move the bell in different ways, such as hitting the bell bottom, gently fiddling the bell, or using the tassel. This indicates that in future designs, playfulness and interactivity can be expanded to the parts of the bell mentioned before. The user also shared that as each bell has its own note, it would be clearer to arrange them in sequence of the length of rope, playing notes from low to high. Lastly, they expressed that there should be a switch mode to change the instrument sounds freely. However, the current prototype cannot be tested for the standing inside setting. According to the feedback, we envisioned that for future design, we will allow players to freely switch instruments and add multiple interactivities to various parts of the bell. We think that the Wind Whisper is a quality product. It gives the user a dynamic, playful experience in their own backyard. It can also be used to play fun games with your friends or family with its unique spatial setting, though this mode still needs to be tested with the complete settings and multiple users. The two sets of prototypes, one Wizard of Oz prototype and one single working bell, are sufficient for test and demonstration. They give a good foundation for us to show a person can play and interact with the bells and how they react to the player's actions. Wind Whisper's final design improves on the current one. The final technical implementation will offer the designed functionality for each bell compared to the prototype's only one working bell. And the quality of the materials used will also be improved. For further design, diverse and controllable interactivities will be considered.